Okay, to determine the end behavior of a graph, all we need to look at is the leading term here. First off, we notice with the x to the sixth that it has an even degree. And because the degree is even, that means both ends point in the same direction. So they're both pointing up or they're both pointing down. However, we notice that the leading coefficient is negative. So we can say that both ends point down, and that will be our end behavior of our graph. Let's do this again, but this time we need to look at what would happen if we FOILed all this out. We would have g of x equals, okay, now let's look at our degree. We have an x to the first times an x to the third, because of that third power out there, times another x. So it's like 1 plus 3 plus 1. We're going to have an x to the fifth power, and we need to know whether that will be positive or negative. We've got a negative out front. This x is positive, this x is positive, that x is positive, so it's going to be negative times positive times positive times positive. This is going to be a 1x. A 3x getting cubed makes that a 27x, and a negative 2, we're going to have a negative 54x to the fourth plus dot 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 for this function. We don't care about the rest of the stuff, we're only concerned with that first leading term. Now, since the degree is odd, and because we have a negative leading coefficient, we know two things. We know it's going to have ends that point in the opposite direction. We're going to have a curve that pretty much looks like this right here, and that tells us that the left end points up, and we know that the right end of this graph is going to point down. Now we're being asked to find the zeros of this function, and to do that we've got to solve the equation. We're not used to solving a third degree function, but I do see that this is going to factor using the grouping method. If I factor an x squared out of the first two terms, we are left with x plus 5. And if we factor a minus 1 out of the third and fourth term, we are also left with x plus 5. So this will give us x squared minus 1 times x plus 5, which can factor further because we have the difference of two squares there. X plus 1, x minus 1, and x plus 5. So we can see that our zeros of this function will be negative 1, positive 1, and negative 5. As far as the multiplicities, the number of times they show up, each has multiplicity of 1, meaning none of them show up more than once. Again, we need to find the zeros and state their multiplicities. This time I'm going to factor normally. I notice there's x's in each term and they're all even coefficients. So let's factor out a negative 2x. This will leave us with 3x squared minus 13x plus 14, which will factor once again. We know we're going to have a 3x in one parentheses and x in the other. It turns out we're going to have a minus 7 and a minus 2, and if you check all the terms of FOIL, that will work out. So that tells us we have the following zeros: 0, positive 7/3, and 2. None of these are repeated zeros, so each has multiplicity 1. This next term is already factored for us, so it's easy for us to determine the zeros. They will be 0, negative 1, and 2. Now 0 comes from a term that has an x to the fourth in it, so it has a multiplicity of 4. Negative 1 comes from a parentheses that has an exponent of 3, so that 0 shows up 3 times. thrice and has a multiplicity of 3, and the 2 has an exponent of 2 outside its parentheses, so that tells us the 0 of 2 has a multiplicity of 2. It shows up twice.